So today we have a nice geometrical problem. The given data is all very simple, there is nothing to be explained in that. Now what we have to do is find the value of sine 2x using this diagram and this simple given data. So let us see the solution. How can we solve for this? So first of all, let me tell you a thing that if you were trying to find the value of x so as to get the value of sine of 2x, the method was absolutely wrong. Here it is asked to find the value of sine 2x, so we can even find its direct value. And to do so, we will first label this diagram. So let the height of this right angle triangle be equals to a, and let the base of this right angle triangle be equals to b, and let the hypotenuse be equals to c. Now as per this given data, this line segment has a length that is equals to that line segment. So one of them we have considered the length as equals to b, so other is also going to have a length that is equals to b. Okay, now look, in this particular triangle we have one of its angle as 45 degree and other angle as x. So by angle sum property, we have this particular angle going to be equals to 180 minus 45 plus x. Okay, now what we are going to do is apply the sine rule in the same triangle. So first of all, let us see what is the sine rule. So here is the sine rule. So now we are going to apply the same sine rule in this triangle. So one of the angle of this triangle is 180 minus 45 plus x, and opposite to this is side C. The other angle is 45 and opposite to 45 is b. And now the third angle is x, but the opposite side is not an important side. So we'll compare these two ratios only, taking this angle, this side, this angle, and this particular side. So now let us do that. So now starting with this particular angle, that is 180 minus 45 plus x. So sine of that angle, so sine of 180 minus 45 plus x upon its opposite side, and that is equals to c. And this ratio is equals to sine of 45 upon its opposite side, that is equals to b. So now we can apply a nice trigonometric identity to this particular thing, that is sine of 180 minus 45 plus x. The identity is sine of 180 minus a is equals to sine a. So here we have sine of 180 minus this complete angle, so it will turn out to be sine of that angle. So after applying the identity, we are left with sine of 45 plus x upon c, and this thing is equals to sine of 45 upon b. And now again we can apply a trigonometric identity to this particular thing, sine of addition of two angles. Sine of a plus b is equals to sine a cos b plus cos a sine b. And here in this particular case we have a is equals to 45 and b is equals to x. So now applying this identity to this, so now this thing will turn out to be sine of 45 degree into cos of x plus cos of 45 degree into sine of x. Now we all know that yes, sine 45 and cos 45 has the same value, that is 1 upon square root of 2. So I will replace them with 1 upon square root of 2, and I can even take common from this all the things. So what we will finally have after taking 1 upon square root of 2 taken common is inside the bracket sine x plus cos x. So this is the final simplified thing of this thing, and upon c, and this thing is equals to sine of 45 upon b. Now sine of 45 has a value that is 1 upon square root of 2 and upon b. And now we can see that 1 upon square root 2, 1 upon square root of 2 got cancelled out. And now after the cross multiplication, we have c upon b is equals to sine x plus cos x. So sine x plus cos x is the value of c upon b. So this is the first important equation, that c upon b is sine x plus cos x. Now look back to the right angle triangle. So what we have just got is the value of c upon b. Now look carefully, in this right angle triangle we can again have the value of c upon b, but in other terms. Now in this right angle triangle we have this complete angle is x plus x 2x. So as per this right angle triangle, if I will take the value of cos of 2x, so this is going to be equals to adjacent upon the hypotenuse. So 2x is this particular angle, so adjacent is equals to b, and the hypotenuse is equals to c. And if I will reciprocal both the sides, I will obtain c upon b is equals to 1 upon cos 2x. So here we have another value of c upon b. And here is the previous equation where c upon b has a value sine x plus cos x, and now we have the value of c upon b is equals to 1 upon cos 2x. So in both the equations we can see their LHS is equal, so we can compare their RHS. So sine x plus cos x, that is the RHS of first equation. So sine x plus cos x is equals to 1 upon cos 2x. Okay, now we will simplify this thing so as to get the value of sine of 2x. Let me show you how. So to do so, we will first square both the sides. So square of the LHS will give me sine square x plus cos square x plus 2 times sine x cos x. So 2 times sine x into cos of x, and this thing is going to be equals to 1 upon cos square 2x. So cos square 2 times x. So now we have this particular equation, and what we can observe is that each and every term of this can be just replaced with some other thing using the trigonometric identities. The first thing that we can observe is that sin square x plus cos square x is equals to 1. That's the universal identity of trigonometry. And using the same thing, we will have the value of cos square 2x, and that is going to be equals to 1 minus sin square 2 times x. And this thing is the direct formula for sin of 2x, that sin of 2x is 2 times sin x cos x. So now we have new values for the old one, so let us rewrite the same equation. So now we have 1 plus sin of 2x, and this thing is equals to 1 upon 1 minus sin square 2 times x. And now what I will do is consider sin 2x as equals to y and rewrite the same equation. So now what we will have is 1 plus y is equals to 1 upon 1 minus y square. We will do cross multiplication for further simplification, so we will have 1 minus y square plus y minus y cube is equals to 1. 1 and 1 got cancelled out, so we have y minus y cube minus y square is equals to 0. We can factor out y, and after the simplification we have this final thing, that y square plus y minus 1 is equals to 0. So here we have a nice quadratic equation, so we can simply apply the quadratic formula so as to get the value of y. So as we will apply the quadratic formula, we have two values of y. The first one is going to be equals to square root of 5 minus 1 upon 2, and the second one is negative square root of 5 negative 1 upon 2. So here we have two values of y. The first one is a positive value and the second one is a negative value. And remember, y was considered as sin 2x, and in this particular question the angle 2x is inscribed in a right angle triangle, so the ratio of sin 2x is going to be a positive value as per this case, so we'll go with only the positive value. So now we finally have the value of sin of 2x, and that is going to be equals to square root of 5 minus 1 upon 2, and that's the answer. In this question we were trying to find the value of sin of 2x, so here it is. What we did is first of all got the value of c upon b, that is sin x plus cos x. Then we again got the value of c upon b, that is 1 upon cos 2x. Then we simplified this normal trigonometric equation so as to get the value of sin of 2x, that is equals to square root of 5 minus 1 upon 2. So this was my way to solve this particular question. If you have any other method other than this, you can do comment below. And if it's hard to comment, you can email me, or else you can send it to me on my Instagram or else Discord. The links are in the description.